Welcome from GTA, Geospatial Technology Associates. In this video, we're going to talk about a Polymer spectral library for the Ninja software. My name is Bill Basener. I'm the president of Geospatial Technology Associates. This picture we have here shows how the Ninja software is used. They have an aircraft, or could be a satellite, collecting hyperspectral imagery on the ground. The data is processed on board the aircraft, which can be sent and accessed by a computer from anywhere in the world with an HTML web link to the computers on board the aircraft. The spectral library that we're going to talk about today is what sits on board the aircraft that tells the software what types of materials they're going to be looking for. And so the material will detect, the software on board the aircraft will detect certain materials in the hyperspectral imagery and then identify them with high precision, and then send the results to any computer anywhere in the world for analysis to determine how certain we are that that is the correct material and what that material is being used for. So in this video, we're going to talk about how we compile spectra for a spectral library, and we're going to talk about this in the context of an example library that includes polymers. And when you're building a spectral library, you want to think of not just the spectra, but actually what the materials are you're going to be looking for and what the features of those spectra are. So let's get started. So first spectra we're going to have in our spectral library is going to be for HDPE, that's high density polyethylene. HDPE is a polymer that's used in hard plastics that are durable outdoors. So here's outdoor furniture made with an HDPE. So a lot of the pipes that would be used outdoor underground, as well as the plastic lumber here refers to the outdoor furniture, geomembrane, so it's used somewhat in membranes on the ground. And so here we have a spectra from an HDPE sample. The next polymer we're going to look at is LDPE, so this is low-density polyethylene. These low-density polyethylenes tend to be flexible plastics, bags, things that can be wrapped. In this example, we have wraps around around bales of hay that help them to be stored for a long time. And so here's the spectrum. When you build a spectral library, you want a number of different spectra for the materials that you're going to be looking for. Next polymer spectra is going to be polystyrene. You can see this polymer tends to be used in small items, and so it's not something we expect to have a lot, but we're going to have it in our library as a polymer to be looking for as well. Polypropylene is another important polymer. It's again used for small things, food containers. Here's a polypropylene cord, and so here's a spectra that we're going to be using for polypropylene. Polyethylene terephthalate is another polymer, and this is one that we might see outdoors. It's used a lot for fibers, and it's called polyester when it's used in clothes, so it can be made in a way that covers fibers. And so one common example is these greenhouse covers that are made out of peat, and peat is used there because it makes a durable fiber. And so just to clarify, when we say we have a spectral library, so we showed one exemplar spectra for HDPE. Our library actually will have 10, ideally 40 different exemplar spectra for each material. And so here's a number of our different spectra for HDPE. And you could see they all tend to have features at the same spot. So all these features have a dip here. HDPE should always have a dip there, some sort of a dip here, this sharp dip here, and you can see some of the features that are distinctive of HDPE, although the slopes and the ratios from one dip to the next peak can vary among the spectra for the same material. But one of the important things is the wavelength at which these minima occur shouldn't vary very much within your different spectra. That should be specific because that depends on the specific chemical bonds that are present in that material. So you can get some of the sense. Some of these little minor fluctuations, those are noise, because some of these were collected from imagery versus an ASD, which will give you a better cleaner spectrum, but sometimes, if you're careful, spectra from imagery can be useful under the right circumstances. If they're collected and converted to reflectance and they're pure, can be useful. So here's an example of one spectra from each of our polymers, just to give you an idea of the variation in the different types of features we have. And so here's our 5 polymers we're going to be looking for. Again, our library that we use for detection identification has 10 or more examples for each of these materials. But this allows you to see some of the distinctive features that will allow us to distinguish one spectra from another spectrum. Thank you very much again from GTA, Geospatial Technology Associates.